Welcome back to Medinare. In this video, let's discuss about development of teeth. When the embryo is about 3.5 weeks old, the stomodium, also known as the primitive oral cavity, is bound superiorly by forebrain and inferiorly by cardiac bulge. The oral ectoderm lines the stomodium, which is a stratified squamous epithelium. This oral ectoderm is separated from the endoderm of the foregut by a membrane called as buccopharyngeal membrane. But this membrane ruptures in 4th week and it leads to a connection between stomodium and foregut. The oral epithelium covers the underlying embryonic connective tissue called the ectomesenchyme. It is derived from the neural crest cells. When these two structures, that is the oral epithelium and the ectomesenchyme, interact, tooth development begins. When embryo is about 5 to 6 weeks old, certain basal cells of the oral ectoderm proliferate faster than the adjacent cells. It leads to formation of primary epithelial band. Primary epithelial band is roughly horseshoe shaped and corresponds to the position of future dental arches of upper and lower jaws. This primary epithelial band gives rise to dental lamina and vestibular lamina. The cells in the dental lamina proliferates to form dental placodes. They protrude into the underlying ectomesenchyme and thereby forms the enamel organ of deciduous teeth, which is future 10 maxillary and mandibular teeth. Okay, now this is where primary or deciduous teeth develop. But what about permanent teeth? For this, the dental lamina also gives out lingual extensions which are called successional lamina. These will be present lingual to the enamel organ of the deciduous teeth. This will give rise to the permanent teeth. However, the permanent molar doesn't need the successional lamina and they directly develop from the dental lamina. The second subdivision of primary epithelial band present in front of the dental lamina is called the vestibular lamina, which gives rise to the vestibule. During enamel organ formation, the ectomesenchymal cells proliferate and condensation of these ectomesenchyme occurs. This process ultimately leads to formation of dental papilla, dental follicle and enamel organ, which are together called as tooth germ. Enamel is derived from enamel organ, dentin and pulp is derived from dental papilla, and cementum, pedial, which is periodontal ligament, and alveolar bone is derived from dental follicle. There are 4 stages of tooth development. They are bud stage, cap stage, bell stage, and advanced bell stage. In bud stage, the enamel organ takes the shape of a bud. At center, it has polygonal cells and at periphery, it has low columnar cells. The next stage is called the cap stage. At this stage, the enamel organ assumes the shape of a cap. This is because of uneven proliferation of cells in enamel organ. That is, the central inner epithelial cells proliferate but the cells adjacent to it doesn't proliferate and therefore the epithelium becomes concave. At this stage, the enamel organ constitutes of inner enamel epithelium, outer enamel epithelium and stellate reticulum. The outer enamel epithelium forms the convex portion of the cap, which are cuboidal in shape. The inner enamel epithelium lines the concavity of the cap and are columnar shaped. The stellate reticulum are star-shaped cells. Let's see how are they formed. The cells present in the center are polygonal in shape, which are present in between the inner enamel epithelium and outer enamel epithelium. These cells synthesize glycosaminoglycans which are secreted into the extracellular compartment between the epithelial cells. Since these glycosaminoglycans are hydrophilic in nature, they pull water into the enamel organ from the surrounding ectomesenchyme by means of osmotic force. Hence, these polygonal cells are forced apart, yet the cells maintain contact with each other by desmosomal junctions, which leads to the star shape of the cells. The cells of the dental papilla appear more crowded in this stage. The dental papilla also shows sign of becoming more vascular. The next stage is bell stage, where the enamel organ takes up the shape of a bell. The 2 major events that takes place at this stage are morphodifferentiation and histodifferentiation. The 4 different types of epithelial cells of the enamel organ that can be identified in this stage are inner enamel epithelium, stratum intermedium, stellate reticulum and outer enamel epithelium. The place on the junction between the inner enamel epithelium and outer enamel epithelium is known as cervical lobe, also known as zone of reflection. At this stage, the inner enamel epithelium, which are columnar cells, gets converted into amyloblasts, which are tall columnar cells. These amyloblasts are responsible for enamel formation. The next layer adjacent to the inner enamel epithelium is stratum intermedium. Some layers of squamous cells seen between the inner enamel epithelium and stellate reticulum are called stratum intermedium. They are associated with protein synthesis and transport of nutrients to the amyloblast. They consist of moderate number of mitochondria, bundle of filaments, well-developed Golgi apparatus, and numerous ribosomes, tonofilaments, and acid mucopolysaccharides and glycogen deposits. They exhibit a high enzyme alkaline phosphatase activity. This layer also plays an important role in regulating the formation of enamel. The next layer present above the stratum intermedium is stellate reticulum. They serve to protect the underlying inner enamel epithelium. After a layer of dentin is laid down, the inner enamel epithelial cells are deprived of nutritional supply from the dental papilla. The stellate reticulum collapses before the formation of enamel, thus bringing the capillaries in the dental follicle closer to the inner enamel epithelial cells to provide nutrition. The next layer above the stellate reticulum is outer enamel epithelium. The outer enamel epithelium is made of cuboidal cells, and the outer enamel epithelial layer is smooth in the initial stages. As the stellate reticulum collapses before enamel formation, this layer is laid into folds, thus bringing the capillaries present in the dental follicle or dental sac closer to the amyloblast. The dental lamina at this stage disintegrates, but some disintegrated fragments may persist, which leads to supernumerary teeth, odontogenic cyst, or odontogenic tumors. Also at this stage, the inner enamel epithelial cells secrete growth factors. This leads to differentiation of dental papilla cells to odontoblasts. The inner enamel epithelial cells differentiated into amyloblasts by the influence of the odontoblast. Now the amyloblasts stop dividing, but the adjacent undifferentiated cells divide and exert pressure. Also, cervical loop restricts the inner enamel epithelium to divide further. Thereby, it causes buckling of enamel organ, which helps in taking the future shape of the cusp of the teeth. Advanced bell stage. At this stage, the mineralization of enamel and dentine takes place, stellate reticulum collapses, and the amyloblast and outer enamel epithelium fuses, forming reduced enamel epithelium surrounding the crown. The cervical loop where the outer enamel epithelium and inner enamel epithelium meet now starts to proliferate. So this forms Herdwick's epithelial root sheath. The root sheath bends at 45 degrees, forming the epithelial diaphragm. Now the root sheath continues to grow coronally, which means the tip of the root sheath doesn't grow. The part which is coronal to the tip of the root sheath starts to proliferate, and thereby the root is formed. The inner layer of root sheath differentiates the dental papilla cells to form odontoblasts, and these odontoblasts are responsible for dentin formation. Once the dentin gets mineralized, the adjacent root sheath cells disintegrates and becomes discontinuous. Now, the dental follicle cells interact with the dentine, which leads to formation of cementoblasts, and these cementoblasts are responsible for cementum formation. And that brings us to the end of the video. I hope you guys found it helpful. Do like this video and subscribe to Medinare for more. Thanks for watching.